In this video, I'm only looking at the fossil fuels that are used to generate electricity. That is natural gas, oil and coal. These three fossil fuels all have different main uses. Coal, for instance, 90% of coal is used to make electricity. So the biggest part for natural gas is heating and electricity. So it's like half the houses in the US are heated with natural gas. Oil, of course, has only a very little part in electricity. It's mainly used as backup emergency generators, like for instance hospitals that will kick in if there's no electricity left, and in that case they do make sense and they have their purpose because they are small but can generate enough energy and you can store the fuel quite easily. Oil, of course, is mostly used for transportation. Oil-free use thermal combustion, so as a fuel they are used to heat water up, and the steam powers a turbine, and that turbine powers a generator. It is also a process very much in the hands of physics. The energy loss in this equation is at around 60%.
All of this means we use up a lot of these energy sources. All of these fossil fuels are finite resources. They were created over billions of years from either fossilized marine microorganisms, that's oil and gas, or fossilized plants, coal. How long will they last? That's not an exact science. Here you can see in 1980, people were convinced that the natural gas reserves would only last for 30 years. Now in 2020 it's 40 years. When we discover new techniques or new resources, that affects the numbers.
Coal seams are pretty much all over the world, and quite a bit of it is still economic to source. The main coal producers, China, India, Indonesia, Australia and USA, are also the main users of coal.
Though in these graphics there's always a strong reflection of population size rather than actual consumption or production per person. This is how it looks with energy use per person. Could we run out of coal?
We've got a lot of coal reserves, but it really depends on what coal we want. Depending on that, we have the different reserves.
And how much of these reserves we use. If we use up all the coal, then yes, coal will run out.
When we phase out coal, this will never become a problem.
The situation for natural gas is different.
Natural gas is seen as a transition stage between coal, which we really need to phase out because of the high carbon content, and the renewables. Users tend to be Europe and the US.
But if you check the per person consumption, then Russia is ahead, followed by Canada.
Producers, Russia, the Emirates, US, and so on. So we actually have so much more natural gas now than we used to is because of fracking. It's now much more economically feasible to get the gas out of the ground.
What is fracking? Used for already emptied wells where you can still find some of the gas in the cracks.
The water is poured into the earth, so the gas has to go up, and as such can be captured. Right now there's also a lot of talk, especially in the US, concerning environmental problems they've had and their experience with natural gas, especially concerning fracking. There might be a shift depending on which reserves are actually cleared in the long run to use and which not. As you use up coal and natural gas, producing more energy than you need doesn't make any sense. What you do instead is you produce just enough.
This is called the minimum demand grid, or the traditional grid. The future grid would be a maximum demand grid, meaning that we have more energy than we need. With renewables, nothing is used up. And where we would, if necessary, connect more or less things to the big grid and have multiple microgrids take care of the local energy demand. What factors decide which energy source we use? Biggest factors are price and availability. This can be analyzed as capacity of each energy source. The net capacity factor is the unitless ratio of actual electrical energy output over a given period of time to the theoretical maximum electrical energy output over that period. Energy source with the least fluctuation is geothermal, the one with the highest numbers is nuclear. Coal and gas tend to be more expensive. As such, if there's a cheaper alternative, the customers will prefer that. With the fossil fuels, it depends on the availability of that power plant. So is there maintenance going on? Has the facility tripped? The capacity factor can vary very much from power plant to power plant and from country to country. As we have just seen in the other graphic, also in this graphic, in the capacity factor, nuclear is first, followed by geothermal, and then only you've got gas and coal. Here you can see the actual electricity generation by source. Nuclear is third on the list, coal and natural gas first and second. That was the US numbers. Now if you take a look here at the UK, in 2021, nuclear facilities, for instance, only had the capacity factor 58. So it really is all very individual. The prices from 2019, the coal prices have been relatively stable. The gas price here is very down, it's gone up since then, but what stays true is that the gas combined cycle plants tend to be relatively cheap, while the gas peakers, they are very much on top. And if you take a look at the renewables, most of them are cheaper now.
Coal is transported to the plant. As such, transportation can take up to 25% of the costs.
Availability of coal.
Coal is not seasonal or has any problems during the day. Coal plants need time to start. You can easily see that when you barbecue, it takes time for the coal to burn. And it's also more costly to start up and power down. As such, a coal facility that only works during peak hours is not really used well.
Both coal and gas have problems with extreme weather events. Because if they haven't been built for certain conditions, then they simply cannot function in them, and then they trip. That means they malfunction. Which is hilarious given that both coal and gas cause extreme weather events by climate change.
In case the facility trips, they always need a secondary power source as a backup.
These backup facilities or peaking facilities are very expensive when they are needed. In a minimum energy grid, they can make up a large amount of the yearly electrical cost, even if they are only employed for a few weeks in the year.
Natural gas, they tend to be the backup or peaking facility, meaning that if there's more energy needed, then usually the gas power plants are the ones who power up, because they can start in seconds. The fun thing is, at the beginning I thought the fossil fuels are a bad idea because of the emissions. They are a bad idea economically. The only people who gain from this are the very rich. One of the simple things would be to cut the subsidies. Let the free market decide which way to go. It may come as a shock to everyone who thinks that the renewables are highly subsidized. Actually, the fossil fuels are higher subsidized than the renewables. So in 2021, globally, the subsidies for fossil fuels were 440 billion US dollars, as you can see here. This is where policies come into play, because as long as the fossil fuel industry has this advantage over the renewables will simply not be able to catch up. How our politicians have managed to choose the worst option?
One of the big arguments for politicians are always the jobs.
Jobs in the coal industry tend to be for lower qualified, and they are also very hazardous, especially if they do not get the necessary safety equipment. By profession, I'm actually a nurse. I've worked in a hospital where we had former coal miners. It was heartbreaking to have these comparatively young men
with pneumoconiosis.
I'm deeply grateful for everybody who works in a mine, and I think we are doing everybody a favor when this isn't necessary anymore.
The reason why coal mining is so dangerous is because of pollution. Here are the big emitting points of coal: sulfur dioxide, nitrogen oxides, particulates, carbon dioxide, mercury and other heavy metals, fly ash and bottom ash.
The mortality figures with coal mostly come from pollution. Coal is one of the most polluting fossil fuels.
This graphic illustrates the coal pollution very nicely. It's done by the San Juan Citizens Group. They've been fighting against oil, coal and gas since 1986. And you can see that coal pollution is locally already a very, very big deal. Here they have nicely shown all the ways it can impact on the environment. As you can see here, for natural gas, the situation is different. It is less polluting than coal. It produces a lot less sulfur dioxide or nitrogen oxide. And as a gas, it doesn't produce any dust. It also produces a lot less carbon dioxide. But the big problem are the methane emissions. Fugitive emissions, which means emissions from the oil and gas industries, are rising and really rising more and more, and now are almost on the level with agriculture. Methane is very, very dangerous in the short term, especially concerning the tipping points, because it traps 28 times more heat in the atmosphere than carbon dioxide. That means it can cause us to have a lot of heating in a very short time, and there we can reach the first tipping points. And in that case, we are in a lot of trouble. And then we cannot just return back, even if the methane is then out of the atmosphere in 12 years.
One of the biggest problems with this energy source are leaks. Leaks are usually not fixed because it's too expensive. As such, we have quite a bit of methane that through leaks just goes up into the air.
Here's some contested problems with natural gas. None of this is clear-cut, clearly researched yet. The main reason for that is that the natural gas companies don't want that research to happen. Contested, how much and where does methane leak? Uncontested, methane leaks. Result, nobody has to do anything about it. Uncontested, fracking uses a lot of water and sand with small quantities of toxin. Contested, how toxic is the water? Can it be safely reused? Is it safely stored underground? Result, nothing's done about the pollution and emissions. Uncontested, damage done to the health when you live close to natural gas and oil wells. Contested, what causes these health effects? Result, nothing is done to protect mainly low-income neighborhoods close to natural gas and oil wells. It's uncontested that small earthquakes can be caused from fracking. It's contested that big earthquakes can be caused from fracking. And the result is nobody is held accountable for the damage, even though there is really mounting evidence that bigger earthquakes can also be caused from fracking, not just from wastewater disposal.
And the conclusion is really, if we were to only use coal as an energy source, in that game of Russian roulette, we'd lose 100%. Is there a silver bullet in coal? No. Even the better facilities using coal, which use carbon capture and other technology to keep the emissions low, A, there are still emissions, and B, it's just too expensive. If we play Russian roulette with natural gas, if we actually fix the leaks and do everything we can to reduce the emissions, we might get that to 3 bullet, but that is not a silver bullet. That is still a pretty sure death sentence. I would never want to play Russian roulette with even 1 bullet, so forget about 3. The really good news in the energy generation part is the global emissions in this sector are expected to plateau between 2023, that would be this year, or 2 years, 2025. Why? Well, because the renewables are up and running. And here are just some crazy stories concerning natural gas and coal. Coal mines, they can burn pretty much forever. And natural gas has to be transported. Very famous Nord Stream pipeline. Security-wise, it's not always good to get most of your energy from outside your own country.